Good morning, everyone. Thank you for being here. It is a pleasure to share this conference with you. We're going to be talking today about how you think about security, securing the access to your data, to your applications when you come to GCP. And we've really done a lot of, we've been working very hard. We have a lot of interesting new concepts to share with you. So we're going to take a holistic approach about how to think about the security and access control, securing your data when you're coming to a Google Cloud Platform. My name is Ines Envid, by the way. I'm a product manager in cloud, and I'll be sharing the stage with Samrat, who's another product manager. We'll have the pleasure to have here Two Sigma, who is a customer who will be sharing their journey to the cloud and how they use Google security. And then we will have finally a walk through partnerships and the ecosystem that we're building as well. So with that, let's get started. How are we thinking about Google Cloud Platform security in your deployment? So when you move your deployments to the cloud, then it is important that you are able to maintain your same security posture that you have today for your deployments. But then when it comes to the implementation, the setup of policies, the enforcement of those, it really requires a little bit of a change of mindset. The reason is that there are a lot of different types of deployments. There are infrastructure as a service, for example, with VM instances. There can be as well Google Cloud, Google Kubernetes deployments. There could be as well Google managed services, for example, storage or BigQuery, and it is important that we provide a holistic approach for security for all of them. So for example, if you take storage, Google Cloud Storage, it is really the access to the data is through APIs. That means that, and those services are really managed by Google, so that means that when you're applying securities, you will need to control the policies in a different way because it needs to be based on really attributes and conditions that are extracted from those API calls so that you can restrict the access, for example, to the data from specific sources, and you can as well have the ability to restrict exfiltration so that, for example, API calls cannot really take the data outside to destinations that are not trusted by you. How are we looking at the framework for setting up policies? So leveraging on our very vast infrastructure, we recommend that you are setting up policies first on the edge. So that, meaning the edge is like if you're explicitly announcing public apps, for example, through load balancers, you can set up those policies that we are going to enforce in our front ends. And we have a large infrastructure to mitigate attacks, and I'll talk a little bit more about that. And then from there, you go to the core where the endpoints are hosted in cloud. Another concept that I will be talking in the framework is we are enable setup of policies that can be centralized managed, but also they're context aware. So meaning that when you are setting up your policies, it is not only networking construct that you can use, but also identities, the resources, the projects from, in which you're accessing the data. So let's walk through that framework. So how do you think about setting up the access control to your resources? So first, if you're exposing public-facing applications, you should be considering setting up the policies with Cloud Armor to expose those. Cloud Armor is, you can think of it as a web application firewall. It applies to HTTP, HTTPS load balancers. It also applies to TCP, SSL proxies load balancers. And then it can actually mitigate attacks at application layer or at L3, L4, at the edge, and we really are enforcing those policies in our front ends, which are distributed around the globe. Now, as you are going into your private deployments, you may want to think of setting up a perimeter in which you consider your deployments trusted. And we are allowing that perimeter to be set up for both VM deployments, Kubernetes engine deployments, and also for Google Managed Services. And this is really what we will be spending a lot of time talking about, how we're actually thinking of building a perimeter for accessing data to those managed services. Finally, you have the capability to apply fine-grained policies where there are application-specific conditions that need to be applied in the communication within that perimeter, so that you can actually have a micro-segmentation of how your application and your services talk with each other. So let's walk through everything together. Again, first, think about how you're protecting your public applications, and then we have a load balancer with Cloud Armor, and that integrates with identity-aware proxy, so that as well you can set up your conditions of what you allow or deny based on the identity of the user that is trying to access those public-facing applications. Second, if you want to build kind of a macro zone in which you are considered trusted your services, you can use for GCVM's VPC level firewalls. You can use, if it's Google Managed Services like storage and BigQuery, VPC Service Control, which expands the concept for these managed services, and we'll talk a little bit more later. And if you're looking at micro-segmentation, then you can apply firewalls based on service accounts, which identify the applications that are set up within that VPC. You can use network policies for your Google Kubernetes deployments. And you can as well use IAM for more fine-grained conditions for who's accessing the data for your Google Managed Services. So starting from the edge to the micro-segmentation. Now, Cloud Armor allows you to set up your rules language. It is a pre-rich rules language which allows you to set up conditions based on application level, but also L3, L4. So you have a lot of flexibility to build your rules. There are also some policies and rules that are pre-canned, so that you can just consume them for specific patterns. When you are now connecting your trusted applications, if you have either VM instances or you have Kubernetes clusters, you can set up VPC firewalls so that you can set up your perimeter. You can extend that securely to your own premises as well. And now, this is what we want to share here specifically with you today. Now we are allowing as well to have that concept of service perimeter for the Google Managed Services. What that means is that if you are hosting data in storage buckets, in BigQuery data sets, you are setting up, you can set up policies which are able to express that only the access of this data within that perimeter, which can be extended to on-premises, is going to allow to access those buckets. So we're actually checking source control, not only the identity, the token identity of the user, but we are matching that up with a source from which that user is accessing that data. Similarly, we are also checking when there is an egress action, for example, to write the data, that the data, it is not being sent to a destination which is outside that perimeter. And then finally, we have a fine-grained control. Just quickly, there is a micro-segmentation set of policies. Using service account is very convenient. Service account is the identity of your jobs. You can set up firewall rules using that identity of the jobs to set up policy across those services. You can use network policies to set up the communication control for your containers and pods is based on namespaces, so you can control which namespaces can talk to which ones. And you can have as well IAM for setting up more control-grained identity access control to specific resources in, for example, buckets or data sets in BigQuery. And with that, I really want to spend some time explaining how we're thinking about providing that capabilities for avoiding exfiltration of your data and building that perimeter for your for the data that you're hosting, either in storage, BigQuery, or any of our managed services. I'm going to welcome on stage Samrat Ray, who's the product manager for VPC Service Controls, and he's going to explain how this works.
Thank you, Ines. So as Ines mentioned, and she explained, the concepts and principles of security that you have been utilizing on-premise don't change, but the application of those concepts and principles, when you come to cloud, you have to optimize them for cloud. And one of the areas which is very different on cloud from your on-premise is that of managed services. So we are going to dive a little deeper into that specific area, since the application is different from how you are typically used to with sort of L3 or L4 constructs that you use to create perimeters on-prem. So VPC Service Controls, they effectively, it extends your perimeter security paradigm into fully managed services, services that are exposed via APIs, those where the resources themselves don't have distinct L3 identities, right? They don't have distinct IP addresses, which you can safeguard behind a firewall, right? In doing so, by providing a perimeter security, it helps you mitigate data exfiltration risks. You can also use this perimeter as a way to privately access your data from GCP, but also from on-premise. I think, as Ines mentioned, if you do want to grant access from the internet, you can use context awareness to determine the level of trust in a very application-centric manner versus just the fact that you are within the network, right? So you can use other artifacts to grant access. And finally, this is really a tool for organizational administrators. So one of the challenges with IAM traditionally has been across all public clouds is the delegation model, because IAM tends to be fine-grained policy management. A lot of times, IAM admins or IAM administration itself of the policies tend to get delegated, and then you have to do things like monitor for compliance, et cetera, which can be painful. We have purposely designed this to be a very macro, coarse-grained posture that you can implement, which the IAM administrators cannot override. So it's a great way to implement your sort of mandatory minimum security controls, right? And then you can have further fine-grained application-specific controls defined through IAM. So we talked about data exfiltration. So it's important to understand how can data exfiltration occur from managed services and why that is an issue on public clouds. So typically what would happen is that your standard firewall, say your VPC network firewall, you would set a policy like allow all access to GCS. So it would be like storage.googleapis.com, for example, right? What that means is you can not only access your own buckets, you can pretty much access any buckets, right? Because your firewall is not aware of the resource model of GCS up on cloud, or BigQuery, or for that matter, any of the services that you're consuming that are fully managed. So that leads to certain risks that you're exposed to. The first is that your IAM becomes sort of a single point of failure for your security. So if you have misconfigured IAM policies, and they may be intentional or for malicious reasons or just for convenience reasons, right? You land up accidentally exposing data. And this has been it's been in the news a lot, right? Like this particular S3 bucket or something else got exposed, and it's fundamentally a lot of that. If you go back and look at the cause, it's the first one. But then that's not the only thing. You can have somebody stealing identities, and phishing and stolen identities are fairly common, right? We talked elsewhere about how to prevent your identities being stolen using YubiKeys and our phishing capabilities. But nevertheless, you still want to assume that the identity has been phished or the token has been stolen, in which case somebody could access the data from the internet pretty much and then push it to Dropbox, right? And that's an exfiltration. The third is you actually have an insider who, and this is one of the more difficult things to control for. So here you can just mitigate the risk versus eliminate the risk in this particular case, but you can mitigate it significantly. Is they're either using compromised code running in a VM or directly accessing the bucket themselves and running as simple as a gcs.copy command. That's all you need, right, to move pretty much terabytes of data from buckets that you own to public buckets or buckets that belongs to the attacker, right? So these are the paths that we have shown here, which are exposed to the risk. So effectively what VPC Service Controls does is it creates a virtual perimeter around the resources of your managed services, like GCS buckets or BigQuery datasets, and it then also maps that perimeter to one or more VPC networks. So you can simply add your host project where your VPC network is defined into the virtual service perimeter, and therefore all VMs in that network then have access to the resources within the perimeter, within the service perimeter, but the VMs don't have access to resources that are outside the perimeter. So even if you read the data into a VM, you cannot write the data to a resource that's outside the perimeter. Further, your service-to-service communications, like copy calls from, say, GCS copy call example that I gave, or BigQuery trying to query a GCS bucket, these kind of pathways are also controlled by this perimeter. So what it does for you is allows you to effectively take your data that's sitting in a fully managed service and make it private, right? And it provides, in that sense, an ingress control, right? Controls access from the internet. So access from the internet is denied by default, and an egress control. So you prevent the copying of data outside to unauthorized projects. Ines did cover this, so I'll go through this fairly quickly. You can extend this security posture to your on-prem if you're connected over VPN or private interconnect. Your on-prem machines also will not be able to, if you use this technology and you access our data privately, you will also not be able to, even from on-prem, you'll not be able to access unauthorized GCS resources or buckets. So your exfiltration control is propagated all the way to on-premise. And lastly, if you do want to open up access, you can do things like only allow access from an IP range. That's sort of the L3 equivalent. But you can do something more sophisticated, like I will only allow access from a managed device given a YubiKey touch and so on and so forth, right? So that gives you this full context-aware access to the perimeter. With that, I'll show you how you can easily define these policies and manage them centrally at scale. Demo, please. Great. So this product is under private beta right now. So if you're whitelisted at this point in time, or if you wait for us to be in the public beta, either in one of those cases, you would see a couple of menu items, one that says VPC Service Controls, the other that says Access Context Manager. So Access Context Manager is the tool that allows you to define these sort of access levels that gives you context-aware access. But today we'll do a quick demo of VPC Service Controls, the core product that allows you to build a perimeter. So in this world, what we are going to have is, I'm going to show you while starting up, I'll start building a new perimeter, and I'll show you the structure of the projects that exist. So let's just call it prod perimeter, and let's look at the projects. So in the projects, I'm just going to filter it by over here, so we can narrow down to the projects that are relevant to this demo. So I've created an attacker project to represent the unauthorized project that has a GCS bucket in it. We also have a compute VM, which I'm going to use to explain how I'm accessing data from within the network, for example, right? And a storage project that actually has the bucket containing PII, right? So before I create the perimeter, I just wanted to show you a quick exfiltration paths here. I hope you can hear me when I keep the mic down. There you go. So the one I have got on my left-hand side, the menu, is on my laptop. So think of it as a client that connects from the internet, right? On the right is I actually SSH'd into the VM that is inside the production network, right? So I'm going to first demonstrate that this is my bucket that is actually my production bucket, the VPSC secure bucket, and I am able to access it from my laptop, which is from the internet, and I'm also able to access it from my production environment. And I have my attacker bucket, which obviously I should be able to also be able to access from the internet, right? It got no data in it. And here's the issue which we have, which is you can also access it from the production environment, right? So here's the exfiltration path. It's very complicated, as you will see. It's this CP command that I run over here from my production environment, and I'm done. And now, let's look at the attacker bucket from the internet. There you go. My PII is out on the internet, right? That's all I needed to do. And it's available now with no IAM permissions, because the attacker bucket is a public bucket. So your data is now exposed to the internet with just this one CP command. Now, this is, because it's so simple, you do want to mitigate this risk. And the way we mitigate this risk, I'm going to quickly delete the data for, sorry. Okay. There you go. I'll just delete the data for now from the attacker bucket. But now we'll set up the actual perimeter. So we are now going to add the projects which I just showed you, except for the attacker buckets. We will add the other buckets into all the other projects into a service perimeter, which I've called prod perimeter here. So we'll say add all these 3 projects. So as you can see, I don't have to do anything GCS specific or BigQuery specific. This is one of the powers of this control, is that it allows you to have a very homogeneous or way of doing this across different service types. Now I say which services do I want to protect here? Let's say I want to protect the GCS API, the Cloud Storage API, and the Bigtable API, because those are the services that I care about. So I'm going to protect those 2. I don't choose an access level. When I don't choose an access level, that means there is no access from the internet, i.e. the data is private. So let's do that. Let's save it. And there you go. It's created a prod perimeter, as you can see, and it has the 3 projects in there and the two services that it's protecting. So let's go back. Sometimes it takes a little time to roll out the configuration because this is a global configuration, but let's give it a quick try to see if it's in place. So now let's run the copy command again and let's see what happens. The access was denied because you could no longer exfiltrate the data. And similarly, if you try to now access the private bucket from the internet, right, you will be denied access to the private bucket from the. So now you have segmented your access. Your internet-facing client can access the attacker bucket, but not the secure bucket. And your production system can access the secure bucket, but not the attacker bucket, right? So it's now fully segmented, and your exfiltration paths have been closed out, right? You can then grant access pretty simply using Access Context Manager if you wanted to grant access from the internet. So you can define different access levels. And then when you go back to your service controls page, you can go back to your perimeter, and you can simply decide which access level do you want to use to grant access to resources in this service perimeter, right? So for example, I could choose something like high trust and do a save. That means only clients that are within this definition of high trust, which is in this IP range, are allowed to access the data. That's it. Thank you. Can we go back to the slides, please? And with that, I would like to invite upon stage our colleagues from, or customers to Sigma to talk about how they have used this to mitigate their exfiltration risk in a real-world deployment. Thank you.
I'll just click on the green button there. Great.
Hi, guys. So my name's Tony Walker, and I work for Two Sigma. So to give you a quick elevator pitch, Two Sigma is an investment manager that uses a mixture of data science and technology to derive insights into the future that help us uncover value in markets worldwide. To give you some more interesting information, we currently have around 35 petabytes of data that we store. We collect that data from over around 10,000 sources. And in terms of our compute footprint, we have about 95,000 cores and somewhere around 1.8 terabytes of memory. I work in our public cloud engineering group, so our group is focused on finding ways in which we can leverage the capabilities of public cloud providers like Google to improve the productivity of our engineering teams.
Thanks, Tony. My name is Nick. I work in security. My team is a partner team to Tony's team, and we work very closely together on focusing on public cloud platform security. A lot of what Samrat and Ines had talked about, we use pretty extensively. If you think about our business in the terms that Tony described it, one of our key assets really is our IP, and protecting our IP is really crucial to us. So when we think about threat models and security controls, really we're very focused on trying to mitigate data exfiltration. So I'm going to talk a little bit about how we used, we have a full stack of controls, but specifically about VPC Service Controls and how we use that in a real use case for our business. So we had a use case where we had a research team who wanted to work on massive data sets. So part of our business is dealing with external vendor data sets, and often these are huge, multiple terabytes. We had a team who trialed BigQuery and loved it and wanted to really roll us out to a production use case. So in order for us to enable this, we had a couple of considerations, and we tried to get an MVP up and running to get this team going as quickly as possible. But we did have to make a number of concessions in order to have our security constraints met. And what you see up on the screen is a very simplified diagram. We've hand-waved a little what the vendor data pipeline is, but we had a way that data could get into a GCP project. And we created this GCP project as a standalone environment that was not directly connected to our internal network. So we were accessing this over our internet proxies from inside of 2 Sigma. And what we had to do then is a lot of extensive research, developing IAM roles that were really essentially read-only. There was a moving target, so there was a lot of complexity there and a lot of tech debt that we racked up. But what we eventually ended up going with was creating home servers in the GCP project that were GCE instances with service accounts bound to them. And the role that the service account had gave our researchers and engineers the permissions they needed to interact with BigQuery and GCS and other core services. The way they accessed those, also from within 2 Sigma, also hand-waved a little, is we had a bastion type environment where we were able to restrict things like copying and pasting, SCP, but still give them shell level access so that they could then start to iterate. One of the key benefits here was they were able to start to work on those data sets and process them and create research. And we were able to get them up and running really quickly, but there were quite a few drawbacks as well. And I'll hand back to Tony to talk about some of the drawbacks.
Thanks, Nick. Yeah, so as Nick said, this got us up and running very quickly, but there were some downsides. So if we start with the home server, this was a real disconnect for our users. So Nick mentioned the Bastion access. So this added an additional hop. A lot of the researchers wanted to use tools that they were used to using on their home servers inside 2 Sigma, but to actually get out and play with the data in a read-write manner, they had to go out onto the home servers to do this. This also, as Nick mentioned, added the complexity that we had to deal with 2 different IAM identities. We had to have a 2 Sigma user that was read-only and an external identity that gave them the full read-write access. Another big problem was the fact that this was connected over the internet and went via a proxy. So often one of the common use cases the researchers would have is that they would want to join local 2 Sigma data with data that they had from the vendors, and there was no good way for them to do this because essentially this was exfiltration. So what they ended up having to do was raise a JIRA, they would put in a request, their manager would have to approve it, and then it would go to Nick and his team, and they would then have to jump onto a secure site and push the data up. And we're talking terabytes of data multiple times in a week. We ended up having to coalesce those requests to once a week. And as you can imagine, this was a real problem for trying to remain agile for our teams. Uploading was one problem, downloading was also another problem. So the corporate proxies, we use these to ensure that our security perimeter is kept well put together for users for internet access. But when we had the research teams wanting to download terabytes of data at the same time, we would often find that they would have either performance problems or actual terminated jobs, and also other engineering groups completely independent from them in 2 Sigma were suffering as well. So these were some real problems, and Nick's going to talk a bit now about what we did to fix that.
Thank you. Being a design partner with Google, we didn't want to develop solutions that were less than optimal or would rack up even more tech debt on our side. So we decided to reach out to Google, and we engaged with the network services team, Samrat and Ines's team. We talked about our requirements and what our considerations were, and also what our security model was, and some of the threats that we wanted to mitigate. And serendipitously, it worked out that at the same time, they were starting to develop the concept of what is now VPC Service Controls. So we spent a lot of time in design sessions with the product and engineering teams, kind of understanding what the roadmap was, sort of communicating what our considerations were, and then we're really early adopters. We obviously did our validation testing, our sort of form of penetration testing, and then we're able to create an environment that was sort of version 2 of what we have here, where we tried to solve some of the problems that Tony had highlighted. So up there, I'm going to let Tony go into more detail about some of the steps that we took to address kind of some of those shortcomings.
Thanks, Nick. So yeah, as you can see, the diagram that's up here is very similar to what we had before, with 2 really key differences. So 1, the GCP project is now in its own secure perimeter, and 2, the project is directly connected to 2 Sigma via private cloud interconnect. Now, this introduced major benefits for us. First of all, users could now safely use all of the native services directly from inside 2 Sigma from their home servers. We didn't have to maintain these dual identities for them, so the IAM complexity that I mentioned before was essentially removed. Additionally, now that we're going directly over the private interconnects, the upload and the download problem disappeared. Users could push data with impunity because there was no exfiltration risk, and they could download over a pipe which was much, much bigger than what we were delivering via our standard internet access. Some side benefits. By removing the need for these Bastion and home servers, we actually reduced the infrastructure that had to remain in the project, so we actually saved ourselves some money as well. So ultimately, this resulted in a major velocity jump for the group that was doing the research, and we quickly realized that this was going to be something that was going to be very popular throughout the company. So what we wanted to do was to try and standardize this into a general platform that we could roll out to anyone. Now, before we did this, there was one technical thing that we had to overcome, and that is that to use the secure perimeter access, the perimeter project has to advertise a route back to your internal network over which you can access all the APIs. And this was fine for doing this with a proof of concept that we had here, but as you can imagine, if we were doing this for potentially hundreds of these projects, we needed to find a way that we could scale that, and Nick's going to talk a bit more about that now.
Thank you. Again, we didn't want to engineer something ourselves, so to a man with a hammer, everything looks like a nail. We'd had success previously working with the Google team, so we decided to reach back out again and explain what our new situation was. And in this case, again, it turned out that it was timely because Google were thinking about the concept of how to bridge multiple secure perimeters together. At the time, there was a product or a feature of VPC Service Controls called zone bridges. And really, this led us to a platform that you see now. At a very high level, what zone bridges are is you can take 2 individual perimeters and you can create a bridge between them such that the APIs can be securely accessed from each individual project. So you can define essentially multiple different perimeters, and when you need them to interconnect, you can have them interconnect, or you can keep them completely distinct. So how we built this into an architecture that really worked out for us was we defined a single, what we called like a gateway project for GCP, and really what the role of that was twofold. The first role was to advertise that route back to 2 Sigma that Tony was just talking about to access the secure APIs. So that was our path into access to the secure perimeters. The other thing that it did was also represent our internal network and internal systems itself as a source secure perimeter so that we could then bridge that perimeter with other perimeters that we wanted to grant access to and enable access to native Google services from within 2 Sigma in a secure fashion. So this really allowed us to scale horizontally and create multiple different use cases instead of having just that single project. There was one more technical challenge we had to deal with though, and this is maybe diving a little deeper. Again, we've kind of hand-waved again how we got vendor data securely into the project. If you want to learn more about that, we can talk about it afterwards, but it's fairly complex. But the other challenge besides that we had to deal with was when you access the secure API endpoint, it actually lives on a different endpoint. The endpoint is restricted.googleapis.com. So you needed a mechanism by which you could remap any of the calls, like for example, Google Cloud Storage is normally storage.googleapis.com. You needed a mechanism to remap that to restricted.googleapis.com for your clients. At the time, Google's private DNS didn't exist for us inside of the VPC, so we couldn't use that. And we also needed a solution for our internal network. So again, we went and did some research. This time we didn't trouble Google with us. We solved this one ourselves. But we learned that within our own internal DNS infrastructure, there wasn't a mechanism for this called response policy zones. So RPZ is what it's known as. We implemented that, and we were good to go. Any requests for Google APIs were now hitting the restricted endpoints, and our users were good.
Yeah, so in conclusion, this was a real game changer for us. Having private access to the APIs directly from our internal network enabled researchers to get up and running and access to the native tools that we ultimately wanted to roll out across other teams. And unsurprisingly, after we did this, we found many internal teams were coming to us wanting to make use of what this capability gave them. And we expect this to continue as Google rolls out more and more services into VPC Service Controls. So if you're interested, as Nick said, if you're interested in hearing anything more about this at a deeper level, come talk to us afterwards. We'll be outside. And if you think any of this sounds interesting, we're hiring.
So with that, we'll hand over to Vineet to talk about Google's partner ecosystem.
Thank you. Thank you. So you guys heard a lot of great stuff that our Google has been building, the key security concept and features that you can use. In addition to what Google builds, there are partners, security companies that all of you have been working for years and years. We also work closely with those security companies to make sure their solutions can complement what Google can do, so you can seamlessly use those products. So I will cover how we are working with partners and how they complement what Google does in terms of security. So the most important concept to understand first is the shared security model. I wanted to re-emphasize that at the start. So security at the core infrastructure level would be something that Google will provide for you at the infrastructure level, but for your services, your projects, you have to think about how you would secure it, leveraging the technology that Google is building and layering on partner products on top of that. So you have to think about clearly in terms of what things are covered by Google at the infrastructure level, what is your responsibility, and how do you cover that and have a security policy to do that. So there are a lot of Google products, as I mentioned. There are also partner products that complement. This is an eye chart. I wouldn't cover all the boxes, but there are a couple of areas or categories that I would emphasize. For example, the next-gen firewall category, right? They have been around for a long time. Most companies use them. It's a kind of category of products that complement what Google do. And you can think of hardware security module as an example, as another category that companies use, especially in the banking sector. So you can use those products in addition to what Google provides natively to meet different requirements that you have. It could be regulatory requirements, could be you're comfortable using a product from a partner and you want to continue and extend that product into your GCP deployments, you can absolutely do that. So, think about, how you kind of layer on the partner products with what Google provides. So just kind of sharing kind of the ecosystem we have with partners. Over the last, 1 year, we have grown at 4x in terms of security companies. So a huge increase in terms of security, leading names in security who have solutions, a broad category of partners. So, and pretty much all the big names in security that you can think of, any product that you use in security works with GCP now. So you can think about, which categories are relevant in your business, which products you're comfortable using, and you can absolutely go use those products. And most of these products are listed on the Google GCP marketplace, so you can look at the marketplace products that are available, or work with the partners and ask them, how do they support GCP. So I will just not go through all the categories. I will just double-click on a few categories that are very important, especially for folks who are new to GCP. So within next-gen firewalls that I mentioned before, app-level visibility, the hybrid connectivity from cloud to your on-prem deployments are very common use cases that we see. Pretty much, all major next-generation firewalls are supported on GCP, and it's not only supporting them and having their firewall run as a VM in GCP. We're working very closely with leading security companies to build next generation of security solutions. So not just match what used to happen on-prem, but how do we make security better by working with security companies? How do we do it in a more scalable fashion, more automatable fashion? So a lot of interesting stuff, a lot of interesting innovation happening with these partners. And one key concept is that works very well with these next-gen firewalls is the shared VPC concept. So if you guys haven't looked at it, it's a very seamless way of routing all your traffic to a next-gen firewall, having controls at the host project level, and the service projects will be routed, all the traffic will be routed to your host project. So it's a very unique Google feature that works very well with next-gen firewalls. I had been talking to customers and partners, and the comments I got was this is closest we have seen to getting the controls we used to have on-prem in a public cloud environment. So if you haven't looked at it, please do look at it. It's a very strong and useful feature. So next category I want to talk about was application security. So, as you think about how do I protect against application level DDoS attacks, WAF kind of functionality, Ines mentioned about Cloud Armor. So we have a lot of flexibility in this category. As an example, you could use Cloud Armor, the native rules that we have on Cloud Armor. You could have partner rules that partners are generating and ingest them into Cloud Armor. You could have a DNS-based WAF or DNS-based application DDoS protection solution, so you don't deploy anything, it's deployed outside of Google Cloud, or you could use a VM-based solution. So there are a lot of flexibility, a lot of options available, depending on your requirements, your preferences, you can pick any of the options that are available. So next category that's kind of very unique to cloud is the compliance in the cloud category. These are cloud native solutions, companies like Redlock, Dome9, and others that will help you once you are deployed, you want to get a quick check on where do you stand in terms of your PCI compliance. So they can go in, do a quick check and say, hey, you are compliant, or these rules need to be changed to make you more PCI compliant. So this makes your life much easier. So if you compare this with the on-prem world where everything had to be done largely manually, these are kind of partners who can bring in, with just creating a service account, they can generate reports within minutes to tell you where you are. So this helps to kind of get you more compliant, another layer of checks that you can layer in. So other key concept I wanted to share was Cloud Security Command Center. It's a great tool that Google has built. You guys may have seen some of the sessions regarding Cloud Security Command Center. But this is one place where all the threat data, all the kind of visibility of what services, what kind of resources you are using, and you can consolidate all the threat data, all the analysis Google runs on security in the command center, and also add partner products on top of that. So this will be your one place in GCP where you can get all the Google signals, you'll get all the partner signals to see in one dashboard what's going on. So this is, great innovation, simplifies your life. So one place to get a security posture. And we are working closely with companies to kind of take it to the next level as well. So once you have the visibility, how do you make it easier for you to kind of react to that data that you have? With that, I will kind of close on with, just rehashing, I think, what we discussed in this session. I think about, when you're thinking about security, as Ines mentioned, think about security, right from, the perimeter and from your edge to core of your network. And when you're creating security rules, think of security rules from coarse-grained to kind of fine-grained security rules. The service controls are kind of great addition. They're providing great capabilities to get you kind of the next level of security. And think about layering on partner solutions. So a big ecosystem of partners, they provide great capabilities. Think about leveraging them as well. Thank you. Now we have, I think, time for a few questions if anybody has questions.